welcome to this class. This class is all about cart decision tree. Before going to this particular type of the tree, decision tree, let me explain briefly about what is meaning of a tree is. A tree is a way to summarize or understand the data. Whenever we have the huge data available, we need to summarize the data as much as possible so that it is possible for us to understand. There are various techniques are there to summarize, and in this class we'll have a look into the decision tree. So this tree has root nodes as well as child nodes. So can we get to know that how data is categorized or classified? There is a hierarchical structure of a decision tree leads us to final outcome by traversing the through the nodes of the tree. And of course, from upper to lower, and the level of impurity decreases. And when you come to decision tree learning, and also referred as index of decision trees, is one of the predictive modeling approaches used in statistics, data mining, and machine learning. This decision tree uses a tree formation and allows us to observe the data and represent it in the branches to get the conclusions about the item's target value. And this target value represented in the leaf form. Tree models where the target variable can take a discrete set of values are called classification trees. So in these tree structures, leaves represent class labels and branches represents conjunction of features that lead to those class labels. Decision trees where the target variable can take continuous values are called as regression trees. So decision trees are among the most popular machine learning algorithms given their intelligibility and simplicity. Before going to the further discussion, let me summarize what explanation happened as of now. So the full form of this one CART is the algorithm which allows us to prepare decision tree is classification and regression trees. And this is a term introduced by Leo Brinman to refer these decision tree algorithms that can be used for classification or regression predictive modeling problems. It's a type of classification algorithm that is required to build decision trees on the basis of a Gini's purity index. Using this index value only, we are identifying as well as preparing a decision trees. This Gini's impurity index is a basic machine learning algorithm and provides a wide variety of use cases. And for information, we can say that CART is an umbrella word that refers to the following types of decision trees: classification trees and regression trees. Classification here now, the target variable is continuous. The tree is used to find a class into which the target variable is most likely to fall. While regression trees are used to forecast the value of the continuous variable is. Now let me say briefly what exactly Gini index is. Gini index is a CART algorithm which measures a distribution among affection of specific field with the result of instance. It means it can measure how much every mentioned specification is affecting directly to the resultant case. This index is used in real-time scenario also, and data in real which is taken from the real analysis. In many definitions, they have mentioned as an impurity of data, or we can say how much undistributed data is. From this, we can also measure that which data from every field is taking lesser, more part in the decision making in the processes. So further, we can focus on the particular field or variable. CART uses Gini index as a metric is. To go further about this particular algorithm, let's take this an example which is there in most of the textbooks and most of the authors follow it. We also follow same one in understanding of this CART decision tree. And here we have, there are 6 features have been given. One of it is called day, the other one is called decision. The day is 14 days have been given, and decisions are no as well as yes. Based on that, decision is a binary values providing. So yes as well as no is providing. And to come to decision of no or yes, there are 4 features are dependent on that. So the 4 features what you have is outlook, temperature, humidity, and wind. So this decision is a dependent variable on these 4 of them, and these 4 of them are independent variables. And in this, the values of these 4 features, if you see outlook, the outlook set consists of 3 values only: sunny, overcast, as well as rain. So these are only repeating here. When you come to the temperature, only here also 3 values exist: hot, mild, and cool. There are 3 values exist of the temperature. And humidity are only 2 values: high and normal. So this is a binary one. Wind is weak as well as strong. Now in the case of outlook is sunny, temperature is hot, humidity is high, wind is weak, decision is no. So we are not supposed to go out when this all the 4 values are falling down. When here now called yes, when it's overcast, hot, high, and weak, you can go for a outside. Like that, this data set consists of 14 rows and different values are there. Now in the preparation of decision tree, so one of the feature, any of the things, outlook, temperature, humidity, or wind, should become the root node. Should become the root node. Now come to the here now the case of this one is outlook is rain, temperature is mild, humidity is high, and wind is weak. Decision is yes. So we have to identify which one to be considered as a root node. So now we'll find a Gini index that allows to do the work. Now, how do you find the Gini index of each and every feature is, there is a formula have been provided. The formula is 1 minus sigma of pi whole square, where I is equal to 1 to number of classes is. So index is a metric for classification task in CART. It stores sum of square probabilities of each class. Then what is the here now called to identify classes are when the temperature is equal here now, outlook value is equal to sunny, and how many times we have yes, how many times we have no, we need to know. Look at the previous diagram is. So outlook here now, when sunny, this is no, 1. Again sunny, no, 2. Again come to here. So no, what you have is called, no, 3 values exist. This is 1, sunny no 2 times, and also sunny no 3 times. So no 3 times we have, and S is 2 times. So sunny here now you can take S here, sunny yes 2 times. So 2 times 3 times, total instance are 2 plus 3 5. Same time in the outlook value is equal to overcast. How many times we have yes 4 times, no time is 0. So number of instances are 4. Rain is outlook is rain, S is 3 times, no is 3 times, 5 times. So total if you take 5 plus 4, 9 plus 5, 14 instances. Now we need to find Gini index. So we got it. How many instances do you have? The classes here now. So when the here now outlook is sunny and S is here 2 times, no is 3 times. So like this we need to find the Gini index, and the formula will apply this one. To find the formula, we have to do the probability of this one. Probability of S is called how many times? 2 by 5, and no is 3 by 5. Yes or not? So this is called when outlook is equal to sunny, 1 minus 2 by 5 whole square minus 3 by 5 whole square. So value comes out here now is 0.48. The overcast, 1 minus 4 by 4 whole square minus 0 by 4 whole square, value is 0. And rain, the value is 0.48. Now what we got is called, we got the weights of each and every values are. How much weight it is carrying using the probability function, we got it. Now we'll apply these weights to in doing the calculations is overall total is. So total overall Sunny is 5 times. So that's why 5 by 14 into 0.48 plus 4 by 14 because forecast 4 by 14 into 0 plus rain is 5 by 14 into 0.48. The value has come in 0.342 has come. Now we go to next one, the temperature one here. The temperature, what do you have is called the second one we take into considerations. Now in temperature, how many cases, how many times do you have called hot, cool as well as mild? When it is the hot, how many times we have yes, how many times we have no? How many times we have called when the temperature is called cool, how many times do you have yes, how many times we have no? When temperature is called mild, how many times we have yes, how many times we have no? So this is the one to do this one. So 1 by here now 1 minus 2 by 4 whole square minus 2 by 4 whole square. Value is coming 0.5. In the cool, 0.375. It is mild, the value is 0.445. The weighting factors, we got it. Now we'll multiply it. So this is called 4 by 14 into 0.5. This is called 4 by 14 into 0.375 and also 6 by 4 into 0.445. The total value is equal to 0.439. Okay. So now come to the next, what do you have is called the humidity is. Humidity is yes and no. So in this yes, 3 times yes, 4 times no, total instance is 7. And normal, 3 times, 6 times yes, 1 time no, total is 7 is coming. Now Gini index of the small the values are 0.367. And when wind is equal to weak as well as strong, that time what do you have is called 0.375, 0.5 as well as the total value is coming is 0.428. So we have all the values of Gini index of all 4 of them. Outlook 0.342, temperature 0.439, humidity is 0.667, and wind is 0.428. The minimum of this one should be taken into consideration. The feature value is the lowest one. This is 0.342. The feature is outlook. So now outlook becomes the root node. Outlook becomes the root node now because of the lowest cost is involved. Now the sunny, when sunny is happening, what is that to be done? When outlook is sunny, okay, when outlook is sunny, so what do you have is called? Okay, we need to take it out. When outlook here now sunny, so we have to write down all these things. So sunny no, as well as sunny no, sunny yes, all this you need to prepare this one separate one, you have to keep it. Okay, this one. So no, yes. So how many do you have? There are 5 instances are there. Now outlook is sunny. Now outlook is rain. Another we have called 5 instances are there. Okay, when outlook is overcast, there are 4 instances we have. You see total is 14 is coming. So in this case, what you have fortunately is when you see how outlook is overcast, all the decisions are yes only. That means irrespective of temperature values, humidity values, as well as wind values, when the outlook is overcast, decision is yes. And outlook is called sunny, but 2 binary values are coming, yes and no. Now outlook is called rain, 2 values are coming. So now again we have to split this this particular data set into further, and also the rain also we have to split. Again you have to start the cycle for this also. That is called finding the Gini index. Now come to here now. What do you have our values are? Outlook sunny, temperature hot, humidity high, weak, wind is weak, no decision. For the temperature, humidity, wind, we'll do the activity of finding the Gini index. So Gini of temperature for sunny outlook, this is the one to find out number of instance, how many do you have? So that also we have showing this diagram is. Yes. Okay, this is showing for the this particular one is. Now Gini of outlook is equal sunny and temperature is equal hot. And how many times we have called no, how many times we have yes. The probabilities you are writing here now. For cool, for mild, and overall is called sunny, and temperature is called weighting factor taken, and 0.2 has come. Right? When for sunny outlook, what do you have is called SC 3 times, SC 0, and no is 3 times, 3, and no 2 times, no is 0 times, SC 2 times, instance 2 times. So now when you found this one is called Gini indexes, all the values are 0, 0, 0 because of 1 minus 0 by 3 minus 3 by 3, 1 minus 2 by 2 whole square minus 0 by 2. Okay. Now if you see called 0 is the answer. Now Gini of wind for sunny outlook. This is the values to be calculated, and overall is decision tree for sunny outlook is when the temperature for the temperature 0.2, humidity is 0, wind is 0.466. Sunny outlook for that. Okay, so now come here now. When the humidity is higher, the decision is no happening, and the humidity is normal, decision is happening yes. Means when outlook is sunny, humidity is high, so no. When outlook is sunny, humidity is normal, decision is yes. Okay, this is the next version of decision trees. Now we go for rain also. Rain also coming like this, rain outlook, you can see here now. So we have two decisions are there, yes and no. Now again we will do the Gini index of the rain outlook also, and the values coming are 0.5, 0.444, 0.466. In the whenever rain outlook is equal to rain and temperature is equal to cool, temperature is equal to mild. Okay, for these values, these are the coming total values 0.466. Now for these values, what you have is called in the rain and humidity is high 0.5, 0.444, and 0.466. Just now I said. Now humidity is high and other normal. Okay, and in the rain here now rain outlook is rain and wind is weak, wind is strong. The total value is 0 is coming out. So Gini index is so temperature, humidity, and wind. So this wind is coming 0 values. So this is the one you are taking wind into considerations. So weak this side and strong is this side. So total coming is this is the total one. As seen, decision is always yes when the wind is weak. Other hand, decision is always no when the wind is strong. This means that this branch is over. Thank you very much.